Greetings and welcome to the video on research questions. Let me get the title of the lecture up here on our canvas. Research questions. Very fundamental topic for us. A topic that we hit very hard with our thesis students and our dissertation students. It is very difficult to really whittle these things down. So I'm going to start with just a couple of kind of general thoughts or caveats, if you will, about research questions. And the first one I'm just going to mention to you is that research questions should be driven by the literature. In other words, there should be some kind of theoretical rationale for conducting this study. And this is one where students, I think, really struggle with. They don't get into the literature very deep, and they're asking questions that might have already been asked, or they're asking a question that is very vague, and it's really hard to attach potentially a hypothesis to the research question due to its vagueness, which kind of leads us to kind of a second caveat, is that research questions should be clear and testable. And I think this testable piece right here is oftentimes where the students fail, is they'll have a research question that is either so vague or so general, if you will, that you can't actually design an experiment or a quasi-experiment to actually get the answer to the question. And so what we end up doing is spending a good deal of our time with again, these thesis students or with these dissertation students, really just trying to whittle down to what is it that you're actually wanting to be able to do at the end of the day, what is it that you're wanting to infer, and kind of taking these questions and rewriting them with more and more clarity. And then eventually what you'll do is you'll get to a point where you're like, okay, now I understand how I can design an experiment to answer this particular question. The third caveat then, which may already be intuitive to you, is that research questions, I'm just going to call them RQs, research questions, and experimental designs are linked. Well, what do I mean by this? Let's give an example here. Let's just say, we'll start general and we'll get more specific. So let's just give an example. So the research question here, let's just call this research question 1. Does drug X have an effect on the observed outcome? And we're going to call this outcome in our design O. So let's just say, for the sake of argument here, let's just pick a drug. It could be really any drug. Let's pick the drug albuterol. Albuterol is just a drug for asthma. It helps dilate the bronchioles, and so let's just say that the outcome here is what we call forced expiratory volume. So we'll call it, FEV. So this forced expiratory, you don't really need to know what that is. I'm just trying to choose something here. Forced expiratory volume is, you would take the individual and you would have them exhale as much as they can and what we do is we measure the volume of air in the first through the first second of that exhalation. And you can imagine if the bronchioles are smaller, you can expire less air. If the bronchioles are bigger, you can expire more volume of air, and so on and so forth. So let's just say this was the experiment, and it's just say, well, let's draw the experiment out. So you randomly assign folks into a treatment group. They're getting the X, the drug, and you're going to make an observation, and then you're going to randomly assign some folks into a group that doesn't get the treatment, so there's no X, and you're going to measure the outcome. Let's just say you have n equals 10 people getting randomly assigned into this row, and you get another n equals 10 people being randomly assigned into this row. So again, here they're getting albuterol, so this is the albuterol group, and here another word for this is the control. They're getting nothing, or they're getting some kind of placebo. And at the end of the day, what are you going to do? For this O1, you're going to get an X bar here, or a mean of the kind of the albuterol group, and here you're going to get a mean of the placebo group. And this mean, both of these means will be off of 10 individuals. So at the end of the day, you want to compare and say, was the mean FEV of the albuterol group different from the mean FEV of the placebo group? That's really what you're trying to do. And so you can see now that as soon as I understand what your research question is, I can almost then intrinsically start to think of and eliminate and come up with a set of designs that might answer this research question. It's a very testable research question, and you could do many different types of designs. Like this is just a what's called a post-test only. In other words, you're just getting a test that comes after the introduction of the treatment, or the X, and the placebo. You could change this design. I don't want to get too far off topic, but you could change this design to make it look like this, where they get randomly assigned, still 10 individuals. They get a first observation, then they get the treatment, then they get a second observation, randomly assign the second group in, they get an observation, they get the placebo, right? So now you've got a pre-test group and a post-test group. So this is called a pre-test post-test control group design here, and this one over here was called just a post-test only control group design. So that is kind of I guess the basis that I really want to lay down for you. And we can go into a lot more detail, but research questions should be driven by the literature. They have to be driven by the literature. It has to be a theoretical rationale for them. They should be clear. They should be very, very, very testable, and they're linked to your experimental designs. And that as soon as I understand what that research question is, I can come up with a set of designs for it. So that's the basis here. We'll build off of this concept, which will lead us into our next video, which will be on hypotheses. Thanks for watching the video.